what do we do if we do multi-step conversion when we do mole conversion? So what do we mean by multi-step conversion? Multi-step conversion is gonna happen every time you are given the mass of a certain substance, and then you'll be asked for the number of particles, maybe the number of molecules or number of formula units, or even the number of atoms in a compound. So if ever you're given such a problem, that means you are having a multi-step conversion. So before you can get what you're looking for from the mass, you need to pass by mole first, and then you get the number of particles, and then you eventually move forward to get the number of atoms. Let's take, for example, this first problem. How many atoms of carbon and hydrogen are there in 55 grams or 55.0 grams of methane, CH4? Now take note that the structure of methane is you have in one molecule of methane compound, you have one carbon and four hydrogen atoms. So this 1:4 ratio will compose your one molecule of methane atoms. Now, in this problem, we're given the mass and we need to get the number of atoms of carbon and hydrogen in the compound. So that means we can't go right away from mass to number of atoms without passing through our mole and the number of particles. So it says here in the diagram that for mass, we need to start by multiplying or dividing your given 55.0 grams of methane by its molar mass. Now, how do we know the molar mass of methane? Molar mass of methane is one carbon, let me write it here, one carbon and four hydrogen. So one carbon is 12.01 in the periodic table. For each hydrogen, you have a mass of 1.01. So this is 12.01 and this is 4.04. Then we add this will now become 16.05 grams per mole. So that means, what does this value mean? This value means that for every 1 mole of methane, it weighs 16.05 grams. So now we can put it here. Where do we put our 16.5 and where do we put our 1 mole? Our target is to remove the gram. So that means we will put the 16.05 grams below, and then of course the 1 mole on top, so we can get what we're looking for in the first step, which is the mole. So the mole has to be on top. Then the next step is Avogadro's number. We need to multiply it by Avogadro's number. What does an Avogadro's number mean? That means mole, in 1 mole of anything, it contains 6.022 times 10 to the power of 23. I put EXP here to emphasize that we need to use EXP function in the calculator. So this is how we're going to do it. So for every 1 mole, we put the 1 mole below because we need to cancel out the mole from the molar mass. And of course, our 6.022 times 10 to the power of 23. Now, what should be the unit here? Of course, you can't go to the unit of atoms yet because you are given a compound, CH4. So that means the first thing you need to get is really how many molecules of CH4 are there. Okay? So we need to get molecules of CH4 first. So let's get the answer to this first two-step calculation. So let us cancel out the units first. So gram CH4 will cancel out, mole CH4 will cancel out, and then we're left with molecule CH4. So inputting everything in the calculator, so we have 555.0 grams divided by 16.05 times 6.022 times 10 to the power of 23 molecules of CH4 will give you an answer of 2.06 up to 2 decimal places only times 10 to the power of 24. And the label here should be molecules CH4. Okay, I hope you're still following. So what does this answer mean? This means that in your sample of 55 grams, that's what you weigh in the weighing scale, that sample of 55 grams has this much of molecules of CH4. So if you have this much of molecules of CH4, and you know that in the diagram here, you see that here, in one molecule of CH4, it contains 4 hydrogen atoms and 1 carbon per molecule. So how do we now get the answer to this? To get the number of atoms and carbon and hydrogen. So let us look at this number here. We can approach it two ways. So to get the number of carbon, all we need to do is look at the ratio. In one molecule of carbon, so let me write down my molecule. So that is 2.06 times 10 to the power of 24 molecules. We can write it as MC. MC molecules of CH4 times, in one molecule of CH4, you have one carbon atom. So in other words, just multiply your 2.06 times 10 to the power of 24 by 1. And so you get the answer to be still 2.06 times 10 to the power of 24 carbon atoms. So that is how we can approach the getting of carbon atoms. How about if you want to get hydrogen atoms? So to get hydrogen atoms, the same, but the multiplier will be different. So we still copy the number of molecules. So we have 2.06 times 10 to the power of 24 molecules of CH4. And since we know that in one molecule of CH4, for every one compound of CH4, there are 4 hydrogen atoms. Therefore, 2.06 times 4, you get 8.24 times 10 to the power of 24 H or hydrogen atoms. So, in this case, we already have the actual number of hydrogen atoms. So, let's look at the answers now. From getting the number of molecules of CH4, we know that it has the same number of carbon atoms because for every one molecule, we only have one carbon atom. But we have 4 times as much as hydrogen atoms in our 55-gram sample because in every compound of CH4, there are 4 hydrogen atoms. So that's how you do multi-step if you are given the mass, and then you are to get the number of atoms. What if we do the reverse? So what if we do the reverse? We're given the number of atoms and then we go getting the mass. So it's same idea, but it's going to be the reverse of what I just discussed. So how do we do this? Let's look at this example. What is the mass of a sample of NH3 ammonia that contains 4.50 times 10 to the power of 24 atoms of nitrogen? So we begin with the number of atoms. Then we divide it by the subscript of that element we're talking about. So we write 4.50 times 10 to the power of 24 N atoms. And since we want to get to the compounds first, then we have to look at the ratio that in one molecule of NH3, we have, wait for a while. So in one molecule of NH3, we have 1 nitrogen atom. So it's just 1 times Avogadro's number will now be below, so 6.02 times 10 to the 23 molecules of NH3 for every 1 mole. And then we go on to its molar mass. So times 1 mole is equal to 17.04 grams NH3. So cancel out the units you don't need. And so putting everything in the calculator will give us 42.46 grams of nitrogen atoms. So this is the mass of the atoms of nitrogen that's present in your sample of substance. Thank you.